So we want to show that when we differentiate this, we get this. So I'm going to let y be equal to ln x over x cubed. And then that is a quotient. So u is ln x, v is x cubed. And so du dx is 1 over x, and dv dx is 3x squared. So dy dx is given to us by v du dx, so x cubed times 1 over x is x squared. Take away u dv dx, so that's 3x squared ln x, all divided by v squared, which is going to be x to the power 6, x cubed squared. So on the top here, I can take out an x squared, and then I've got 1 take away 3 ln x over x to the 6, and then we can cancel the x squared with the x to the 6 to get 1 minus 3 ln x over x to the power 4. Find the exact coordinates of the stationary point of the curve. So we need dy dx to be equal to 0. And that means the numerator here is 0. So 1 take away 3 ln x is equal to 0. So 3 ln x is equal to 1. So that means that ln x is equal to 1/3. Take the exponential function of both sides. And of course this is just x. So that's x equals e to the 1/3. Now y then is going to be ln e to the 1/3 over e to the 1/3 cubed, and the top there is just going to be, we'll drop that down, 1/3 ln e, so that's just 1/3, and the bottom is just going to be e, and having a fraction on a fraction's no good, so that 3, slide it down to the bottom, and we've got 1 over 3e. So our stationary point is at e to the 1/3, 1 over 3e. And use the result from part 1 to find this integral. Okay, so what we know is that the integral of this expression, the integral of 1 take away 3 ln x over x to the 4 dx must be what we started with, which was ln x over x cubed, plus some constant, obviously. So let's split this. So that's the integral of 1 over x to the 4. Take away the integral of 3 ln x over x to the 4 is going to be ln x over x cubed plus a. And rearranging that, that gives us the integral of 3 ln x over x to the 4 would be equal to the integral of x to the negative 4, which is this. I've taken this essentially to this side, so everything else is coming over. So we've got take away ln x over x cubed plus some constant. So I've got 3 times the integral of ln x over x to the 4. No, that's 3 times what I'm trying to find, is equal to, so we've got x to the negative 3 over negative 3, take away ln x over x cubed plus some constant. So 3 times the integral of ln x over x to the 4 is equal to negative 1 over 3x cubed. Take away ln x over x cubed plus a constant, and then finally the integral that we're trying to find. Just divide through it by 3, so 1 over 9x cubed. Take away ln x over 3x cubed plus a constant.